Hey guys, I'm back and this time I'm back with Fibre Channel topologies. In order to understand these Fibre Channel topologies, we first need to understand what a Fibre Channel is, why we are using Fibre Channel. Now, I decided to bring up this topic because I've already given a lecture or a video on zoning and how it is done. But in order to reach to zoning, you have to know what the topologies are and why we are actually doing zoning. So, beginning with what is a fiber channel? A fiber channel is a high speed network technology which is used to connect servers to data storage area networks. Now, data storage area networks are nothing but just SAN. Fiber channel technologies handle high performance disk storage for applications on many corporate networks, and it supports data backups, clustering, and replication as well. Why Fabric Channel? Fabric Channel is nowadays, in trend because of its speed, distance. It can travel long distances, 30 meters for a copper cable, hundreds of meters for today's multi-mode fiber, and thousands of meters for tomorrow's single-mode fiber. It also offers flexibility, different connecting protocols, that is topologies, is the reason behind its flexibility, which is going to be our main topic today. I'll be coming to it in a couple of slides. And most importantly, because of the above three factors, it has now become an industry standard interconnect for clusters and SAN. It is also an important disk interface as well. Talking about what are the topologies that are used to bring about the flexibility that we talked that fiber channel have. Fiber channels basically have three main topologies. One being the simplest point-to-point topology, as the name suggests, is just a node connecting to another node. Second being fiber channel arbitrated loop, which in general terms is, in SAN world is referred to as FCAL topology. Third one is switched fabric topologies, which is the latest and which is mainly used these days for any networking, SAN networking things. To go ahead and understand the topologies, we need to know some definitions, some terminologies, and the naming convention that we have used for ports. So, in general, there is an N port, which is a node port, which is referred to as in point-to-point connections. There's an NL port, which is a node port connected in an arbitrated loop. There's an F port, which is a fabric port. There's a fabric port in arbitrated loop, which is FL port. There's an L port. L port is the port that is basically hub port in the arbitrated loop. So, I'm going to talk about what an arbitrated loop is, what a fabric is, where we're using, point to point and everything in details. So I'm giving this overview for you to understand about the terms that we'll be using in our next slides basically. So coming to our next slide, which has some more terms that are important to be known when you're working with fiber channel, is going to be your G port. A G port is a generic port that operates in either E port mode or F port mode. E port is an inter-switch expansion port which is used to connect E port of another switch to build a larger fabric. So to explain this, I'll tell you a fabric consists of multiple switches which are interconnected. The ports that are interconnecting these switches are basically called the E ports. What is RX and TX? As the name suggests, they are the receiver and the transmitter. You can go through this definition, which is, just explaining what the name suggests. Moving to our next slide, we'll be explaining all the topologies in details, starting with the point-to-point topology, which is the most basic and the simplest of all topologies. Here, a single link connects only two ports. This topology is inexpensive because there is no requirement of any hub or switch in this case. To create a larger point-to-point configuration, you can provide multiple endpoints on every node. Each point-to-point connection provides the full bandwidth supported by endpoints because there is just one connect on the port, and depending on that link, whether it's multi-mode or single-mode fiber, the two nodes can be separated up to a distance of 500 meter in multi-mode and up to 10 kilometers in single-mode fiber. This kind of topologies is not used in a generic infrastructure now, but as the name suggests, it's point to point. Therefore, you'll be definitely connecting one node to another node through one connection anyway. So next is fiber channel arbitrated loop, which, as name suggests, is basically looping. It's a high-speed FC topology in which fiber channel ports use arbitration to establish a point-to-point circuit and prevent multiple ports from sending frames at the same time. Here the device connected in one-way ring. So, by saying that the devices are connected in a one-way ring, we mean that it has a serial architecture, and the bandwidth of one of the loop is shared between all the ports. Then only two ports can communicate at a time in this, because so when what is happening here is, so when port in a loop topology has an information to transmit, they send an arbitration signal to decide which port can use the channel. Basically, the port in control of the channel then sends an open signal to the destination port and transmits its data. Since all the ports in the loop are connected, therefore every port will see and pass along the data, but ignore the data unless addressed to that particular port. Now, this is one of the disadvantages of this topology, that there is no data security. It is going to the nodes that even don't need it. It has 126 ports, so 0 to 126, making it about 127 devices connected to each other. And though it is still used internally in many fiber channel switches, but there is a very, very rare scenario where it is still used to connect host to storage. So as you can see in this, there is one ring topology which is working serially. So if one of the devices in this loop fails, what happens? Your data gets lost? Yes, it will. But in order to prevent it and to at least make sure that your data reaches its destination, hubs were introduced. Right? So what a hub will do, it will isolate the dead server and pass the connection basically through the cables. Arbitrated loop has a physical ring. If which ceases to work, then the hub will maintain the logical ring. It will isolate the device or the link that has failed and allows a star topology on the cable level and passes the data or any signal that it was passing by bypassing any inactive or failed ports. The fiber channel hubs therefore have another function, which is that they provide bypass circuits that prevent the loop from breaking. Coming to the most used topology these days, and the latest one, switched fabric topology. Switched fabric topology is basically a network of switches in a fiber channel that are interconnected, forming a fabric. Ports on one node can communicate with ports on another node which is on the same fabric, and many connections can be active at the same time. It totally depends on us whether we want to open entire communication or we want to keep one-on-one communication. Talking about one-on-one communication is where zoning comes into place. That's how we bind two devices so that the communication between them is not shared to the other nodes in the same fabric. So the any-to-any connection service and the peer-to-peer communication service provided by Fabric is basically fundamental to the fiber channel architecture. Fiber channel architecture can support both channel and network protocols simultaneously. It uses intelligent switches basically for its communication to happen. The key advantages of switch fabric topology is that it can support up to 16 million nodes. Yes, you heard it right, 16 million. Switches that can act as routers, that is intelligent switches, which will allow only ports communicating seeing the traffic. That's because of zoning. You can create connections between the ports. High aggregated bandwidth with multiple paths enabled concurrently, and electrical and logical isolation because of the cabling and your zoning definitions. Both you can do hard zoning and you can do soft zoning as well. So these are the three main topologies that basically fabric fiber channel is working on, and switch fabric is the most used one these days. uh, Talking about all this was to present you a basic idea. So, next time when you see my zoning video, you can just come back to this lecture and know why we are doing zoning, how has zoning come into picture, and why we actually started using it. Before fabric switch topology, we never had zoning because there was this arbitrated loop which was anyway giving information to all the nodes. And even before that, we had so much cables in point-to-point connectivity, hence restricting making the infrastructure large. Thank you guys for bearing me through this. To connect with me, you can reach out to me at techgirl23591@gmail.com. And with this, we complete today's content, which was aimed at fiber channel basics and topology, contributing to its flexibility. Thank you.